Alrighty, good afternoon, everyone. Welcome, panelists, audience members, and to our collaborators from LSRC. Happy you could join us for today's event. Do the values of biodiversity scientists bias biodiversity science? Great question. I'll pass it over to our moderator for panelist introductions in just 1 second. But first, welcome to our virtual channel. For those of you who haven't been here with us before, Concordia's fourth space is physically located on unceded Indigenous land in downtown Tiohtià:ke, Montreal, and we operate as a university-wide platform to activate research, teaching, and initiatives so as to connect the public with the inner workings of a university. All of our events are free and open to all, and I invite you to check us out to learn more. I'll put some links in the chat in a minute. I'll also note that we are recording and live streaming this event onto Facebook. All communication channels have been activated in this space: chat, Q&A, and virtual hand raising so that you might speak are all on, and we welcome your participation in this discussion. On that note, to tell you more about today's proceedings, I'm handing it over to Jim Grant. Hi, Jim.
Hi, Anna. Thanks very much to you, Anna, and to Fourth Space for co-hosting our event today. I'm here as the co-director of the Loyola Sustainability Research Center. So welcome to our last event of this academic year. I think we've got a really interesting conversation to bring your way today. But first, I also want to acknowledge that Concordia University is situated on unceded Indigenous land and that Montreal is traditionally known as Tiohtià:ke. Well, we're absolutely delighted to have Dr. Mark Vellend from the University of Sherbrooke here as our keynote speaker. Mark is a professor of biology. He's a distinguished scientist, a community ecologist, and he's got publications in many publications in prestigious journals such as Science, Nature, PNAS, and Ecology Letters. But we've actually invited him here to talk about his other passion. He thinks deeply about his field of science and the practice of conservation biology. And we saw a paper of his that he published in 2019 that was entitled "The Behavioral Economics of Biodiversity Conservation Scientists." And it sounded like a perfect topic for an LSRC conversation. So we've invited Mark today. So thank you, Mark, for coming. We also invited two panelists to make comments or ask questions of Mark. One is a philosopher, Dr. Matthew Barker from our own Department of Philosophy. Matt is an expert in the philosophy of biology, so we thought he would really enjoy this conversation. And our second panelist is Dr. Carly Ziter. Carly's a professor in the Department of Biology, and she's an urban landscape ecologist and a practicing conservation scientist. So probably the target audience for Mark's paper. So, and both Matt and Carly are members of the LSRC. So welcome to Mark, Matt, and Carly. And Mark, thank you for being here. Please take it away.
All right, can everybody see my slide there?
Looks good.
Great, thank you so much. Well, first off, thank you so much for the invitation. It's really great to be here, to be able to talk to you about this, and thanks especially to Matt and Carly for engaging in a really stimulating sort of discussion in advance to sort of see where our various ideas lay. So as Jim said, I'm going to talk about science and values and the interface between them. And so I figured I'd begin by just sort of declaring some of my own values. As you can see in these pictures from a visit last summer to Parc de la Gaspésie, this is on the top of Mont Albert, where we can see a small population of caribou if you're lucky on a given day. And so really large wild spaces with species like caribou and many of the plants and animals that have been here for a very long time are something that I really place a great deal of value on. And so just in case during my talk sometime you have the idea that my membership in the Nature Lovers Club should be revoked, I want to assure you that indeed I am a nature lover. But it's in fact those strongly held values that concern me a little bit in terms of my ability and our collective ability study nature, to study conservation questions with a maximum degree of objectivity, because we bring to the table a bunch of values, sort of certain results that we might like to see more than others, and that can be a potential challenge. So I want to begin by asking you to think about what you see when you look at New Zealand. And I don't mean see in the sort of sense of, there's green and blue on the screen, but ecologically, if we think about the history of New Zealand, what do you think about? It's a really interesting place because, humans have arrived relatively recently in the past. Some 800 years ago, people of Polynesian origin arrived on the islands of New Zealand. Subsequently, a few hundred years ago, people of European origin. And during that time, we've seen a great deal of ecological change, very similar to the kinds of things that have happened in other parts of the world, but they sort of are magnified on islands. So one of the things that happened, or one series of things that have happened, which we often talk about as, biodiversity decline, or biodiversity is in trouble. So since the arrival of people, roughly 3/4 of the forest, which covered most of the islands before, was converted to agricultural or pasture land mostly. Half of the endemic bird species there are now extinct, and there's been a massive influx of non-native species. A lot of those native birds were and are flightless, and so we're very prone to predation by introduced predators. And so on those accounts, it sure looks like biodiversity has declined and that it's in trouble. On the other hand, these are also equally sort of true things that have happened on New Zealand. The number of plant species one can find growing, spontaneously wild on these islands is twice what it was before the arrival of people. Very few species have gone extinct, and about as many as were there before have been introduced and naturalized. Despite the loss of all those bird species, there's about the same number of bird species as there were before. And where there used to be no land mammals at all, now we have dozens of species. And so by any scientifically defensible definition of biodiversity, based on the metrics that people often use, we've seen biodiversity increases for those groups, or at least stasis. And so when I got to thinking about how all of these things have happened, it's sort of a nuanced, complex history of ecological change. And yet when we sort of tell this story outside of our disciplines, 99% of the narrative is about biodiversity decline. And so I started, to wonder, why is that? And is this a problem if there's a sort of complex situation and we're always only telling one side of the story, and why that might be? So another question we can ask is whether or not these changes that humans have made to the islands of New Zealand, have they made the place more able or less able to support human livelihoods? Because often we'll find an emphasis in these losses, because they're presumed to somehow have degraded ecosystem services and the capacity to support human livelihoods. And I think you'd be hard pressed to try to sustain an argument that these changes have in fact made the islands less able to sustain human livelihoods. So these are the kinds of questions that really got me thinking about how our values influence some of the conclusions that we draw from our science and how we go about doing our science to begin with. So if we talk about values, there's at least two categories. I've done lots of reading in this area, but it's not my core area of expertise. But so we can distinguish two important categories here. One are epistemic values, so those related to the creation of knowledge. And so as scientists as a whole tend to be on board with the idea that when we do our science, it's good to be objective and as accurate as possible. If I'm trying to estimate, how many species of birds have gone extinct on New Zealand, I want to estimate that number to the best of my abilities without, somebody lobbying me to have it be a higher number or a lower number, for example. There are also contextual values. So these are our individual preferences with respect to, moral, political, cultural questions. And so, I have my values where I, place great value on, big, large, wild spaces. And so if I'm going to be studying those spaces, there's definitely a potential for there to be some conflict here. This is just human nature. We have individual values, contextual values that might potentially conflict with our capacity to be objective when we go about doing science. And it's this conflict that I want to get into a bit further. So what are our contextual values. And so by our, I mean we, the ecologists and conservation biologists in the crowd. Clearly, not all of us share precisely the same values, but by and large, if we chat amongst ourselves, we'll find a great deal of commonalities. So the field of conservation biology was defined initially by Michael Soule and others, but this is a particularly well-known paper where he established some what he called normative postulates of the field of conservation biology. So essentially, things that values that conservation biologists hold. And a couple of them are that diversity of organisms is good and ecological complexity is good. These are good things, regardless of what we tend to find when we study them scientifically. These are good. In another book by Jonathan Newman and colleagues, they sort of looked across the literature on what ecologists and conservation biologists tend to say in their publications. And there's a fairly clear sense that there's a preference, for example, for natural over modified habitats. So we'd much rather go walking through an old growth sugar maple forest in southern Quebec than a scrubby forest with buckthorn and dandelions. We prefer native species over introduced species and historical versus changed communities. We'd sort of like things if they look like we think they did hundreds of years ago before there were major human modifications. To summarize, we strongly prefer diverse, complex communities of native species that form ecosystems looking like they did historically. And sort of behind all of that is the sort of core premise that justifies the existence of conservation biology to begin with. It's often described as a crisis discipline, the crisis being that these things we value about nature are in trouble. So biodiversity is in serious trouble. That is the justification for the existence of the field. So we have some values and some sort of beliefs or core premises that we bring to the table when we start doing our science. So let's take an example of how these things might play out. So there's me as a undergraduate student in the early 90s. Within a few years, I'll be off to grad school. And so my values at the time and presently were very much like the rest of the ecologists out there. So I really like wild places and creatures, the tranquility of being in nature, and so on. From readings and in class, these really famous people, Paul Ehrlich, E.O. Wilson, they've told me that native species are the best ones. Extinctions might doom humanity, and because I got to be fighting against something, and these are important people. That sounds about right, so it must be true. And so what action do I take? Well, I become an ecologist. I get to spend time in nature, pursue my curiosities, and so on. And so when I get around to my science, what do? I'll find some system that people have screwed up somehow. And in the end, in all likelihood, I'm going to conclude that, in fact, people are bad for biodiversity. When people muck around in nature and do things, it tends to be bad for biodiversity, which in turn, is not good for human well-being. Now let's imagine some other person with a different set of values that they've brought to the table. So this other hypothetical person has no special relationship with nature, but they're not cold-hearted. They have human well-being as a central interest. Their beliefs don't involve any preference for native over non-native species. They can't figure out why one would find red maple preferable to be growing in southern Quebec than Norway maple. And when they look around at a place like New Zealand or anywhere, they think that the human modification of the earth has in fact enhanced human well-being. For whatever reason, they become an ecologist as well, maybe because it pays so well. And when they go about doing science, they decide to study agricultural landscapes, and they come to the conclusion that people have figured out to use land so much more efficiently over time. It's had a huge positive influence on human well-being. Now, if this type of person and the type of person that I am, let's say society is made up of a mixture of those two types of people. Obviously, it's a lot more complex than that. Then if the scientists doing ecology had the same sort of composition, then those biases might sort of balance themselves out. So in short, if the values of a set of scientists trying to discover the workings of nature is broadly representative of the stakeholders that will make use of their information, values might not cause an overt problem, but that seems unlikely to actually be the case. So there's this huge field of science studies, scientists studying other scientists, essentially, sociologists. And when they look at science, they see, a group of people that is clearly unrepresentative of the diverse stakeholders affected by science. And if there are groups of people that, have such a very high degree of common shared values, the influence of them is likely just not even to be noticed. Everyone you ever talk to shares these values, and so they must be sort of universal truths. So we can ask the question, are ecologists' values representative of the broader society? So this, those quotes are sort of about scientists in general. What about ecology specifically? And I don't think there's any chance that the values among ecologists is representative of the range of values that one finds in broader society. I don't actually have any data on ecologists specifically, but I found a couple of studies where, academics in various fields were asked about their, political affiliations. And so those are not, directly, values themselves, but I think we'd all agree that there are likely to be strong correlations there. So if we look across departments in many different disciplines, economics, history, communications, and so on, the ratio of Democrats and Republicans, which I think everybody knows is roughly 50-50, 1-to-1 across the United States. In this study, it was found to be 15-to-1. So more than 90% of the researchers, the faculty members in these disciplines across many different American universities, fell on one side of the political spectrum. In a different study specifically about sociologists, in which almost 500 of them were surveyed, again, something like more than 80-90% of them fall to the middle or to the left of along this political spectrum. So clearly, nowhere close to being representative of the stakeholders out there who are going to be influenced by whatever recommendations for policy come out of these results. And I think it's quite reasonable and safe to assume that ecologists fall somewhere along similar lines. If my conversations at meetings are any indication, it's almost, it's about the same in ecology. So we do not have a representative set of values. So what did I actually do? I gave a little sketch sort of hypothetically, but what kind of study did I actually do back as a grad student? So as a PhD student, I began with this scenario. So I was working in upstate New York, where this sort of history of landscape change was the template for the subsequent studies that I did. So prior to the arrival of Europeans, the records suggest that almost all the landscape was forested. Native peoples most certainly had an influence. It was minor relative to the huge changes that were the consequence of European settlement subsequently. And so today, a relatively small proportion of the landscape is forested, and between those forests are well, who knows what? What we have here is just white space. And so this was a satisfying way to begin a PhD, because probably the most famous book in all of ecology begins with the exact same scenario. So figure 1 in the theory of island biogeography shows the loss of forest in one portion of Wisconsin. So basically we're turning the world into a series of habitat islands. So this is a pretty simple little diagram, but I think there's pretty important consequences of just sort of drawing those spaces between the forest fragments as white space. And so to an ecologist, when we look at it this way, what is the white space? Typically, we talk about those parts of the landscape as having had their habitat destroyed. So essentially it's just non-habitat. There's effectively nothing there. At best, we'll call it something like a matrix. So it's unsuitable habitat that the organisms that live in those forest patches have to somehow cross to get to other good places where they might meet some of their needs. In the real world, what's actually in that white space? So hold on to your hats. There's going to be an amazing animation here. So there's the actual landscape underlying that map of forest fragments and white space. And clearly it's not all homogeneous, nor is it all even pale colored, if you will. So in those spaces between the forests, we have pastures, crop fields, roads, ditches, yards, abandoned fields. And those habitats are home to a great many species that are not found in the forests. And a lot of species that use the forest also use the open habitats, and vice versa. And some of those include beloved species in conservation, such as bobolinks. And so when people actually study sort of entire landscapes, not just the forest fragments themselves, you can find that in fact it's in a landscape with a mix of these habitat types, natural and then human modified, where we find the most diversity. So here's a study from Southern Ontario where the number of bird species you find in a landscape is maximized in places where the proportion of natural area is somewhere between 0 and 100%. And even when the proportion of natural area is close to 0, which means in a landscape like this, it would just all be fields of some kind, you have roughly as many bird species as you do in this landscape where it's all forested. So clearly that white space is not devoid of biodiversity. But this was the model under which I was working, and under which thousands of studies have been done. And so I have this map in front of me. There's forest patches and there's white space in between. And so the consequence for the design of my study is that the species of those non-forested habitats just don't count. Even if I find them in the forest, if they're typical of those open habitats, they don't really count because they're not real forest species. And so when I find trillium plants like this one, a long-lived shade-tolerant plant that really lives almost only in forests, it counts. If I run into one of these tall goldenrod species that's typical of fields, it just doesn't count in my tally when I'm going to assess the biodiversity of plants in this landscape. So before I talk about a couple of results that I found, I want to just sort of clarify that first, we actually looked at two different types of forests. So there were forests that we call ancient or primary forests, the dark green ones, where they had never been converted to agricultural fields, and then these recent or secondary forests where the forest had grown up on abandoned agricultural land. The other thing in this diagram to point out is this beta symbol, which is a different kind of diversity, which is how different patches are from one to the next. So a low value of beta means that those forest patches are very similar in the composition of species there. And if that value is low, we think of having a very homogeneous landscape. So what did I find? I found first that there was lower diversity of forest herbs, these specific plants that live only in forests, in those recent than the ancient forests. So it sounds like this human activity of disturbing the land previously reduces biodiversity. But in fact, had I counted all the species and not just the ones that are forest herbs, I may well have seen the reverse pattern, greater diversity in these disturbed forests. I don't know because I didn't actually take those data. I also found that when you look at the differences between the forest patches, the ones that had a previous agricultural history were much more similar to one another in the species that were present. So we say things like, okay, people's activities have homogenized this landscape. But in fact, if you look across the whole landscape, which includes the old, the young, and all the habitats in the white space, it's almost certain that the overall beta diversity is higher in this contemporary landscape than it was before because of this greatly elevated heterogeneity. So the interesting thing is that when you show results like this to other ecologists and conservation biologists, when you show them results like the ones on the left, they say, yes, of course, we know that when people muck around, it's bad for biodiversity. When you show them results on the right, which you can get from other studies, the reaction is often, well, yeah, but really it's those results on the left that I care about. It's these results showing that things are getting worse that I want to talk about. So sure, that's true, but let's just keep it between us. I'm definitely not alone here. So I could come up with many other examples. This is one that I talk about in the paper that Jim mentioned, where I commend the authors on being very upfront about which species they included and why, but ultimately it leads to a fairly misleading conclusion that we can see in this title. So it says anthropogenic disturbance in tropical forests can double biodiversity loss from deforestation. So we can tell just from reading that there was some biodiversity loss from having eliminated forest, and then just as much biodiversity loss from the disturbances in the remaining patches. So that's quite interesting. Does the paper actually demonstrate that disturbance caused a net loss in biodiversity? If you look carefully, what they actually quantified was what they called conservation value, despite what they've written in the title. And it says that we restricted our analysis to forest species to avoid attributing value to invasive and open area species. So really, based on the data presented, we have no idea whether or not these disturbed forests have less biodiversity in them than undisturbed forests, because we only counted things, or the authors only counted things that they considered to have value. So here's a case where I think there's a sort of a very direct line between values and sort of the results that were put forward. And I think this thing is likely to be quite common. Well, I mean, I can certainly attest to the fact that there are many, many studies that do something similar. Another really fascinating case study where I think the role of bias is even clearer was done by Lenore Farrig. So this is a review paper in which she looked at a huge number of studies focusing specifically on the effects of habitat fragmentation independent of habitat loss. So given that there remains, let's say, 20% of forest in a landscape, is that 20% of forest in lots of little pieces, which would be high fragmentation, or is it in a few larger pieces, which would be low fragmentation? And she found that more than half the time, the responses, whether it's diversity or population size of some target species, are actually positive, which goes against the conventional wisdom about the effects of habitat fragmentation. What I want to focus on is how the authors of the papers who find these effects actually report their results. So I'm going to show a graph in which on the x-axis, we have three types of studies based on what is actually presented in the tables and figures, so the actual data. So studies would either show only negative effects, only positive effects of fragmentation, or some mixture of the two. And then by looking in the abstract, you can see, well, how are these actually described in that portion of the paper that most people are actually going to read? So if there were only negative effects of habitat fragmentation, the authors quite faithfully reported those negative effects. So 80% of the time, was a negative effect. That's what they said in the abstract. What if there was a mix of negative and positive effects? Well, that about 2/3 of the time was described as some sort of mix of effects. The interesting part comes when authors found only positive effects of habitat fragmentation. Less than half the time did they actually say that in the abstract. They would either talk about, there were mixed effects. They would sort of ignore the effects of habitat fragmentation. And even in a few cases, they'd figure out a way to call it a negative effect of habitat fragmentation. And I find it difficult to interpret results like these in any other way than some sort of bias coming in what we want to communicate to the world about our actual empirical findings. Okay, so whoops. Why in other sorts of situations might values be problematic? So among other ecologists I've spoken to, many people like to bemoan the fact, for example, that when you get results from a pharmaceutical company or an oil and gas company, you can't trust the research they do because they have some underlying motivation to find certain things. So if we take the example of a pharmaceutical company, they might bring to the table values of making a lot of money and making drugs that are safe because they want people to buy them. Otherwise, they won't if they're not safe. And then they ask research questions like, well, will the drug help a lot of people, and are the drugs safe? And I think we can see how there's a huge incentive to find certain answers to these questions. And in certain on certain types of questions, ozone, climate, tobacco, that kind of thing, there are very well documented cases in which exactly such biases crept in. What if we look a little closer to home? So there's a great many organizations that I donate to the WWF and the Nature Conservancy every year. Many of us have some links to some of these organizations in terms of research funding and so on. And so the values that are brought to the table by ecologists, for example, are that the diversity of organisms is good. And then we go ask questions like, does biodiversity have instrumental value? We ask the question, is biodiversity good, even though we've already decided that it is good? We have a preference for natural places, and we ask questions like, does human disturbance cause biodiversity to decline? We have a preference for native species, and then we ask questions like, well, do introduced species have negative impacts? This justification for our existence, that all of these things are in trouble, is followed by studies where we ask the question, are the things we value in trouble? And so I hope that it's fairly clear to see that we have certain incentives stemming from our values that might guide us to one type of conclusion instead of another. So on one hand, it sounds objectionable to put next to one another. These organizations, like we see on the top, whose aim is collective good, let's say, versus evil companies that are only interested in the bottom line, and they're greedy and so on. But greed is not the only motivation for reasoning that might deviate from reality. So many psychological studies show that people's values and the desire to belong to whatever group you're in can be a very strong motivator of people's reasoning, just as strong as greed. And so, if we're thinking about feedbacks to science, I would not say or minimize the potential role that these other kinds of values or factors might have in motivating our reasoning, even if we think they are less morally objectionable. So just one more slide. I sort of got amused when I was looking at some of my emails and thinking, well, in fact, some of these organizations also have a financial incentive to be finding certain things. So if you donate money to the World Wildlife Fund, you're going to start getting emails from them regularly. So here's one that I got last fall: biodiversity is our strength. And so they come out, with results from the Living Planet Index, which, as many know, has some issues of its own. Sort of these catastrophic statistics about how terrible shape nature is in, and then that's used not only to generate sympathy, but actually to generate money itself. And so there's actually in some cases a financial incentive to use a certain narrative as well. Okay, so this is my last slide. Just a few final thoughts. So one often hears that a solution to all this might be simply to you take your scientist's hat off and on at will when you're going to be making value judgments versus when you're going to be doing science. And I think I just don't think we can quite use a magic wand that way. It's probably not quite enough to hope that we can sort of just switch these things on and off. And I think we can only gain by sort of really trying to pay attention to whether and how our values might insert subtle but ultimately consequential biases into our science. And there's a great deal being discussed these days about diversity in science. And I really applaud that, but I don't think we think too often about diversity along these axes of values. Are the values that ecologists and conservation biologists have collectively representative of the stakeholders to which they are making policy recommendations? And I think that is worth thinking about a lot more. With that, I thank you for listening, and I really look forward to comments and questions.
Great, thanks a lot, Mark. Great presentation. Lots of ideas for us to think about. So I'll encourage people in the audience, if you have a question, you put it in the Q&A, but we'll first go to our panelists. I wonder, Matthew, do you want to raise any questions with Mark, discuss any aspects of the presentation?
Sure, yeah, and Mark and Carly have been very gracious with their email time the last few days. We've already had some discussion about some of the points in Mark's presentation, and that's been very useful to me. Actually, it's helped me get clear on some things. So I think the plan is I'll just make a quick comment and then ask a question. Everybody can hear me okay, right? Yeah, okay, good. So the comment, I guess, is that it seems like to me there are two kinds of bias that can come in, and this relates to a distinction that Mark made early in the talk between epistemic values and contextual values. So epistemic values are often thought to be the ones that are fine within science. So it's valuing things like predictive accuracy and objectivity and things like that. Whereas contextual values are often thought to they should play less of a role at the core of science anyway. Those, our moral views, aesthetic views, things like that. And I think you can get bias of both types coming in, and in some of Mark's examples, I think you get bias of one sort and bias of another. So for example, when you find that many studies are underreporting data or conclusions that don't fit with their value framework, that can be a problem for knowledge generation in the long run for the community. And so that can be a kind of epistemic failing, right? But in some of the other examples, I think what's going on is because conservation biology is so overtly a value-driven discipline, many of the conclusions are right on the face of it value-laden, right? So they've right in the conclusion, there's some value-laden term like good or bad, or people are bad for biodiversity and things like that. And I think one of the main problems that often comes up is that any argument for a claim that has a partly value-laden or normative aspect, the argument itself isn't going to work unless there's a value-laden principle in it. And of course, you often need empirical principles as well. So you might have some empirical principle like, the diversity in forest type or in forest herbs decreased. That sounds pretty empirical. But in order to get to a value-laden conclusion, you're going to have some other premise in the argument that gives a reason for thinking that kind of decline is a bad thing. And I think often the kind of problem you get in this research and in the communications is that people aren't explicitly teasing out those value-laden premises clearly enough for people. And that's one thing, just making them clear, being upfront about them. But the second thing, and maybe more important, which might be a surprise to many of the people in the field themselves, is that we can give those rational support, right? So just because they're not thought of as the kind of thing you can give empirical support to doesn't mean they're incapable of all rational support. They're not mere matters of opinion in all cases. Sometimes they are. But yeah, making them clearer, distinguishing them from the empirical aspects, and then attempting to give them some kind of rational support. And often that might involve interdisciplinary work, right? In enlisting the services of other people of other expertise. So that was the comment. And the question, I guess, was about a point that came up a couple of times in the talk, which was about representativeness. This is something that Mark and I talked about in email. And I guess my question is just out of curiosity to get further clear on Mark's view on representativeness. I think we both agree that it would be good in several respects if conservation biology, the values found across it were more representative. They represented those of society at large to a larger degree. And I thought that important variable, representativeness, can come apart from the variable of diversity, and that for some purposes, like trying to support conclusions as well as possible, I often think diversity is the more important variable, especially internal diversity within conservation biology. So the question is to imagine a case in which the representativeness problem falls away. So suppose that values across larger society at large become more homogenized in the kind of way we think they already are within conservation biology. So now you have conservation biology matching pretty well, representing pretty well the values across society at large in this fanciful case. But you would still have the problem of not a lot of internal diversity. And now the problem would be in society at large as well. I guess the question is, does that suggest that representativeness is useful currently in the real world just because it happens to track diversity? And really the core variable, if you wanted to start modeling this stuff and studying it, that you'd want to look at is diversity. So that's the question.
Question for me that I should answer?
Yeah,
Okay.
well, or whoever, yeah.
Yeah. Well, I'm just trying to get a sense for the format. I mean, it's a really interesting point, right? So I agree that this hypothetical scenario in which like society itself becomes incredibly homogenous, would we nonetheless try to get some diversity into a field like conservation biology? And I think there are different reasons that diversity, regardless of representativeness, might be a value, or where representativeness is sort of the key. So if you have a democratic society and people have, and scientists are feeding into policies that are meant to essentially reflect the values of that society, then I think representativeness is what you're after. Obviously, we in many of us hold values that would suggest you don't want to trample on minority rights. So if there's some minority that only represents 5% of the people, and we never ever listen to that group of people because 95% of the people have some other type, well, that's problematic as well. And then when we're talking about trying to eliminate biases, when we're sort of seeking to get at least biased characterization of how the world works, that's where sort of diversity, I would agree, comes in, because that whole society might be incapable of sort of seeing the different points of view. And so what the optimal amount of diversity there is hard for me to sort of figure out where we begin. But I think different context would lead you to thinking that one or the other is sort of a more appropriate benchmark about which to think.
Great. Yeah. Thanks, Mark.
Carly, do you want to jump in at this time?
Sure, yeah, I can jump in here. I have so many questions I'd like to ask, and I'm trying to think of which one I want to ask first. And maybe just in the way that Mark started, by kind of putting some of his values forward, I'm going to acknowledge that I spent like a great deal of time and money literally this week ripping grass out of my yard and planting native plants. And so certainly, I would put myself in some respect in that camp of, biodiversity is good. At the same time, I'm probably not the most, exciting or maybe inflammatory panelist you could have brought to this discussion, in the sense that I probably agree with Mark and with a lot of the voices he cites in his written work. Lenore Farrig, who we mentioned in the talk, Emma Maris, more than a lot of my fellow ecologists, and that stems from what I study, right? So I study ecosystem services, or the benefits we get from nature, which is a very value-laden field as well. I study urban systems, which are these incredibly modified systems. So when Mark had his slide of values, I was writing some of them down. The desire for nature to be free of human impacts, a preference for natural over modified habitats, for historical versus change communities. Those don't really align with the way I tend to do my own science. I place a lot of value on modified habitats. I think that these are incredibly, valuable, beautiful, interesting places to do science, which is kind of an unpopular opinion as an ecologist a lot of the time. And so even though I probably fall into that camp personally of kind of biodiversity is good, when I'm putting on my scientist hat, I guess, if we can put that on and off, I try and contextualize that as, okay, biodiversity is good, for who and for what. And I wonder if that, so I guess the question that I would pose first is, how much of this is something that has to do with the actual way that we are, doing the science itself, like the study we're doing, compared to the way that we are communicating and kind of contextualizing those results? Like, do we need to change what we're actually studying, or do we need to change the way that we are communicating this to better frame, to better highlight maybe what our own positionality or our own values are, or to better highlight, where and to what extent those results apply to different groups of people? Is this a science issue? Is this a science communication issue? Is it an intersection?
Oh, and I'll share a couple thoughts. I don't know if Matthew or others are going to want to chime in as well, but I think the potential for values to insert themselves in ways that create bias can occur at all of the steps. So in the cases of my own that I described, it was literally like sort of at the step of which species are going to be on my data sheet that I can tick as present or abundant, or like not even on the list. And so that is definitely part of how we do the science, and it's clearly not quite enough to specify in your methods what you've done, because given that people have this expectation, for example, that when humans go monkeying around in a place, that that the consequences are not going to be good. When they hear your results, even though you've said that you only looked at forest species, there's not a single word in the results that isn't like literally true. it gets filtered that way. And if 9 out of 10 studies make a selection of species, for example, I'm not saying that's true, but if they did, and there's just so much information around us, we're digesting this, and it looks like 9 times out of 10, human activities actually cause the number of species in a local place to go down. The nuance definitely gets lost. There's just such a barrage of studies out there, and then in the communication, I think it can happen there as well. We definitely have, as people very frequently have as a goal, to convince whoever's listening that things are bad, and we need to sort of do something about it. I often think about, everybody's got like that skeptical uncle at your holiday party who like wants to know why the taxpayer is paying you to do what you do. Why should they care about some little fish that lives in one lake that might be disappearing that nobody's ever seen? And it was situations like that where I started to ask myself, like, why is that little fish actually important? Is it actually important? And like, we can come up with tall tales about why it might be, but maybe I've deviated a bit from your question, but it's those can deviate pretty far from the science. But we give them, what bothers me is that we give them the appearance of a scientific opinion when really it's
Right.
my values talking.
So if I can, I know we have audience questions. I'm going to ask one follow-up, and then maybe we can pull in some of those. So if part of this problem is that we are letting our kind of biases influence the questions we ask and the way that we ask them, is there a role, or do you see a role for more of a co-production model of doing science that might help with that? So for example, I as a scientist work with stakeholders and rights holders to come up with the questions that they want answered, and then ask those questions. Is that going to help circumvent some of this if we're getting more input up front on what we're asking?
But I always got to check to make sure I'm unmuted. Potentially it does. And I mean, it does sound like a situation in which, with studies that are very targeted to trying to guide management and policy in a particular setting, where the stakeholders have defined the goals, then many of these issues, just to begin with, become far less problematic, because you're not trying to find a result that's going to define the goal. What you're doing is helping to guide goals that other people have. But certainly overall, I mean, it speaks to what Matthew said about diversity. So if there's a greater diversity of viewpoints, that city council that you're talking is going to have people on it that don't care about that little fish in that pond, and they might have a very rational reason underpinning that. And so that certainly sounds like one way to help circumvent some of this.
Well, maybe I'll take one question from the audience, and then we'll go back. Here's one. Is biotic integrity one of these values that ecologists use? Would this be a classic example for you, Mark? Do you want to think about biotic integrity in your list?
Well, for sure. So there's, like, I can't remember exactly how it's calculated, but there's this thing called a biotic integrity index. And somebody will correct me if I'm wrong, but I'm pretty sure that you define as your baseline state of maximum integrity, or sorry, like a value of, like, your baseline value of integrity as sort of the state in which all of the sort of original species that were somewhere before humans were mucking around have certain abundances. And then to the extent that those go down, then your integrity is compromised. So even if other species come in, it's almost guaranteed to only ever be able to get worse. And so it's a case in which, I mean, if you're going to use that to say that human activities, compromise some important attribute of ecosystems, you have built in to the process a near guarantee that that will be the case. I mean, so to get back to what Carly said, if if a large group of stakeholders has sort of has decided that they would like to have a park in which it remains something like the way it used to always be for cultural values reasons, whatever, and we're scientists is helping them get there, that's no less a justifiable goal than some others. But to somehow say that it's sort of objectively better to be like it used to be is definitely an example where I think values have impinged upon the science in a major way.
Great, thanks, Mark. Matt, did you want to come back into this?
Yeah, that's an interesting example. I think for sure, in that index used for biotic integrity, values are built in. But I want to suggest there's always a further step from that, from the values, inserting themselves to it counting as a bad bias. Whether it's a bias or a bad bias, it depends, because these values can be well argued. People can give strong rational arguments for having the values they do and trying to leverage them in the way that they do. So if somebody can give a very long, carefully argued case for why that's the thing that they value, the thing that the Biotic Integrity Index is measuring, then it's not so clear that it's bias. I mean, you might say, well, but then the scientific process isn't objective. But then I worry that you had something in mind that science can never achieve. I mean, as Mark pointed out, in asking a question at all, you're making a choice between questions that you find interesting or society finds interesting, or that you can give long reasons for finding interesting, but you're still making a choice. And when you decide to collect some data rather than other data, you're making a choice. And when you decide to test one hypothesis against number 2 instead of number 3, you're making a choice. So I hope that there's not some sort of ephemeral idea of objectivity in the background here. Once we realize that values are always playing a role at every stage of science, we're in better position to see that that's not always such a bad thing, and they can do important work. It's that we've got to use them in the right way. We've got to leverage them in the right way.
Good, thanks, Matt. I have a really interesting question here from my colleague, Amy. Amy, do you want to unmute and ask your question, or I can read it? Maybe I'll read it. So Amy says, I'm a social scientist who has worked with ecologists. One of the first things I learned was that edges and disturbed areas tend to be more biodiverse. And one of the second was that not all biodiversity is equal in value. So if these points were part of an outsider's intro to ecology, how can it be that these points are missed among conservation biology? I wonder whether the question is with divisions in scientific communities.
So, I mean, let me say that anybody else wants to chime in is more than welcome to. But I mean, there's two, I guess there were two things in there. One was that the lesson that edges often have more diversity, which can be true. And then you can also find sort of another study that I show in a different sort of talk of this nature was actually about edge effects. And edges of, between the forest and the field, let's say, often have a very different sort of set of things growing there or living there than on sort of either side of the edge. And you'll still get ecologists using terms like, like the ecosystem has been like perturbed, or like clearly negative connotation because it's not like the center of the forest. So if diversity went down, that's what they would tell you. They'd say, look, diversity is lower on the edge, but diversity didn't go down. So they find something else about it that must be worse because it's not as much like as they would like it to be. So they'll say it's been, there's other words that people use that are escaping me at the moment. But anyway, like clearly sort of value laden.
Degraded.
Degraded, exactly. So what was the other one? The other one was oh, that some diversity has more value than others. I mean, that depends on how you value things. So if you're trying, if you state from the outset that there's a particular ecosystem service that you want to maximize, in Carly's case, then there'll be some combinations of species that deliver more of it. Often it's simply that, you know, native species have more value than non-native species, and you're just being asked to accept that. I mean, as Matthew says, somebody can come up with a rational argument, but almost every case I can think of, there's an equally rational argument on the other side. And so the fact that one of the points of view has a rational backing rarely sort of, in my view, tips the balance anyway, which returns me to the same place as we are if they're, quote, mere opinion. Anyway, Carly, what do you think about edges?
Yeah, I mean, I think so. There's a kind of clear analogous situation when we think about cities. So if I think about cities, if I think about Montreal, pretty much every city, if I go and measure the trees, I go in my local neighborhood within like 1 kilometer of me, I'm going to find probably 150 species of trees. If I go out into a Quebec forest full of native species, I'm going to find, what, 50, maybe, depending what we count as a tree,
Maybe.
and like 40. And so, and if we look at, you know, herbaceous plants, that difference is going to be even more stark. This is a well-known, you know, empirically supported over and over result where, because people are planting things, we're bringing in things that we like or that we want, we're adding them to our gardens, we just have a lot more species. And for years, if you read about urban systems, they would be like biodiversity deserts or wastelands, or we'd talk about them as if there was like nothing here but pavement. And I think, I don't know how I think that is a problem in the field with how we reconcile this, where if we're going to say biodiversity is good, then shouldn't we be measuring biodiversity? You know, if we're going to say it's good and we're going to use metrics like species richness, which is the most common one that we use, then picking and choosing like biodiversity is good, but only the good species, I find that very hard to be kind of internally consistent with that kind of a viewpoint. And so I think there is some reconciling there that we need to do as a field. I think it comes back to this idea of thinking about biodiversity is good, you know, for what? Biodiversity is good for who? And so if you are going to state some value, you know, if I'm going to plant a species in my yard and I want to attract native birds, probably planting a native tree species is going to do that better. So if I have that stated goal or that stated value, then maybe I can say, okay, certain subsets of species are going to be more valuable or going to be better. But you need the value first. Like you need to, I'm losing my train of thought here, but I think this goes back to some of what Matt was saying, where there are arguments we can make in terms of things that we might value, but to just have a blanket statement of, you know, these species are good and these species are bad, or this system is degraded and this system is not, that gets us into some problematic territory pretty quickly. I hope we're starting to wrestle with this a little bit more as a field as more people start working in like less pristine systems. You know, as more of us are working in agricultural landscapes, in cities, as we're doing a better job of acknowledging, you know, other knowledge systems, acknowledging that people have actually been impacting our pristine systems for generations, maybe we'll start to add more nuance to these kinds of statements of people are bad for biodiversity or biodiversity is good, but we're not quite there yet as a field.
Thanks, Carly. I'm watching the time here. Matt, did you have a last quick question for Mark, maybe, or comment?
Just to pick up on this, what can be a real problem when two parties or more give what appear to be really well argued rational cases for conflicting values. It can seem like, well, then in the end, it's hard to know how to choose between them. Is it really any different than those being mere matters of opinion just because there are rational arguments under them? And certainly there are cases where we run up against a wall like that, but there are many other cases in which we don't, in which rational deliberation brings out internal errors in people's reasoning. It changes minds between the two camps. There's all kinds of ways that we can make rational progress on value issues. And I think one problem may be in the field of conservation biology is that these things haven't been brought out in the open and debated and questioned in a way that increased diversity within the field might do. That would push people in that direction to get, to get much farther down the chain of rational argument for the value-laden positions that might turn up some resolutions and some agreements. There's always a chance it won't, and that's rough, but it seems like we're early on in the game in this regard.
Thanks, Matt. So last comment to Mark. So Mark, do your colleagues, what kind of response do you get at conservation biology meetings when you give a talk like this?
Well, I can't say I've given this particular talk at a conservation biology meeting. Was at a philosophy meeting, but certainly, I mean, it's sort of related anyway. But if you begin to point out that, in fact, there's a great many situations in which biodiversity just, measured by the metrics that everybody accepts as biodiversity metrics, just isn't going down in a great deal of scenarios. That generated a great deal of disgruntlement and, debate, if you will. Whether it led to reconciliation or resolution, maybe a little bit, sort of, but many other aspects of things just sort of continue, unabated despite that. But I suppose there's one can see incremental progress. I mean, these things take a lot of time, and so just to get people to talk about biodiversity change as opposed to biodiversity loss being the topic, as in like that's the only direction it could go. I think there's already been a bit of a movement on that, and so that might be frustratingly slow, but it's happened all the same. So we'll see if we can push the dial a little further still.
Great, thanks very much, Mark. Well, maybe you should be writing the new value statement for the field. Update it after 35 years. It'd be an interesting attempt, I think. Anyways, so well, I know we are running out of time, and I should first thank you very much, Mark, for virtually coming here to share your really interesting ideas with us. And thank you to Matthew and to Carly for putting so much work into this, way more than I had expected. So thanks very much for this great conversation. And I will turn things back over to Anna.
Thanks, Jim, and thanks for the moderation. I'll just echo those thanks to the panelists. Mark, that was an incredibly accessible presentation and a fantastic way to spend this beautiful Friday afternoon. And as we see by the numbers who joined us, thank you, audience members, for being here as well on this beautiful day. I think this was a very thought-provoking moment for us all, and you all brought so many great questions to the table that I hope we have time to further unravel in upcoming conversations. Carly and Matthew, pleasure of having you here with us. Thank you for your excellent interventions, and we hope to see you all again on our channel soon. On that note, I'll wish you a very warm and happy weekend. Thanks, everybody. Have a great afternoon. Bye, Rebecca. Bye, Jim. Bye, Carly. Bye, Mark.
Thank you all.
Bye, Matthew.
Thanks, everyone. Take care.
Bye, Anna. Nice to see you as always.
Bye, Mark.
Bye.
Bye, Matt.